Hey everyone, welcome back to the next video in the GCSE Maths Series. Today we're looking at angles in parallel lines. So let's get straight into it. First of all, we're going to start off by looking at some basic angle rules. Then we're going to look at different types of angles in parallel lines. Then we're going to look at some solving questions, and as always there'll be a separate video dedicated to exam style questions. So the basic angle rules that we're going to need to know sorry, before we go into any sort of questions is firstly, angles on a straight line add to 180. So if I just draw this like this, angles on a straight line add up to 180. So here we have x degrees, and here we can say we have y degrees, and we can say x plus y is equal to 180 degrees. Hence, angles on this straight line will always equal to 180 degrees. Okay, second rule is that angles around a point, so around a point, are equal to 360 degrees. So this basically means any angle, if you had x here and y here, or even if you had a third angle, z here, all of the angles around a point, a single point here, will equal to 360 degrees. Okay, taking a look at the third rule, vertically opposite angles are equal, and usually we get it looking like this in exam style situations. So these two angles are equal and these two angles are equal because they are vertically opposite from each other, and vertically opposite means just directly opposite each other. So let's look at some different types of alternate angles. Well, I just let the first one out. So alternate angles is when the angles are found in a Z shape. So if I was to draw this out, what it would look like would be two parallel lines, and the way we show parallel is through these arrows like this, and we say that alternate angles are angles which form a Z shape. And here we can clearly see the Z shape here. So these two angles, called it x degrees and x degrees, are always going to be equal when they are found in a Z shape going like that. Also, we can have it going the other way. So if I draw this again, and to say the line's going like this angle and this angle will also be equal because of the Z formed this way. Okay, moving on to the next type of angle, we have corresponding angles. So we have two parallel lines once again, like so. And then we have our line going up like this. Well, let me draw that better. So yeah, we have our two parallel lines once again. Then we have our straight line going like this. We then have two angles, A degrees and B degrees, and these are called corresponding angles, and A is equal to B. Hence, what we're going to do is form our F, and the two angles in the corners or the vertexes of our F are going to be equal. So in this case, A is equal to F A is equal to B degrees. Okay, moving on to the last type of angle in parallel lines, and we have our co-interior angles. So we have our parallel lines once again. We have it going like this, up, and then we have our A degrees and B degrees once again, here and here. And in this case, what we're looking for is our C shape. Our C shape. C for co-interior. That's how I used to remember it. C for co-interior. And what we can say is that A degrees plus B degrees is equal to 180 degrees. Okay. Vertically opposite angles are equal. This is another thing we've looked at before, but I guess we can look at it again. It will come in this sort of frame, and we can say that these two angles and let's say these two angles, when they're vertically opposite from each other, are going to be equal to each other. So now we're going to look at solving some questions. So the first question is, two parallel lines are crossed by a transversal. One angle is 65 degrees and it forms the top part of an F shape. So we have, to draw this out, we have our two vertical lines. We have our transversal line, which is going like this through. We are told that one angle is 65 degrees and it's formed at the top part of an F shape. We are then told to find the corresponding angle, and remember, going back to our definition of corresponding angle, that is the bottom part of our F. So if we form our F, we see that it goes along here. So our bottom part is going to be our 65 degrees here, and we say here the corresponding angle is 65 degrees because corresponding angles are equal. And that is a good enough reason to justify our answer. So looking at number 2, it tells us that two parallel lines are crossed by a transversal. One co-interior angle is 116 degrees. So let's call this one 116 degrees. Find the other co-interior angle. So a co-interior angle, again, remember, we're looking for our C for our co-interior angles, and we want to find the other co-interior angle. So going back here, we can see that co-interior angles add to 180 degrees. Hence, we have to do 180 minus 116 to get our angle, and we say that that is equal to 64 degrees. Okay, looking at number 3 now, it says a diagram shows two parallel lines crossed by a transversal. So two parallel lines crossed by our transversal line. One of the angles on the top left of the crossing is 110 degrees. So I'm guessing that's here. One of the angles on the top left of the crossing, yep. And it asks us to find out what is the angle directly opposite it. So directly opposite will be here, which is going to be 110 degrees. And we can say 110 degrees because directly opposite angles are equal. Okay. What is the alternate angle? Remember, the alternate angle is our Z, and in the two corners, so that will also be 110 degrees because our alternate angles are equal. What is the co-interior angle on the same side? So it now wants us to find this angle here. Hence, we use our rules of co-interior angles and say that co-interior angles add up to 180. So 180 minus 110 is 70, which means the co-interior angle here is 70 degrees because co-interior angles are equal. Okay, that's going to wrap up for today's video. Hope you guys enjoyed. Hope you guys learned something. As always, please make sure to like, comment, and subscribe, and I'll catch you in the next one. Peace.